of you, most welcome in this class again. Today we will start a new subtopic of logarithmic differentiation, that means those problems which has solved by logarithmic methods. In this class we particularly discuss mainly those kinds of problems which is totally different. As we know, in previous class I have already told, whenever you face those kind of problem, could not that means totally will be in complex form, that means more radical terms are available in given expression, or you can tell me there are many terms as a multiplication or a division. As you know that you know only differentiate only those type functions having both function as a product or as a division. But in that case, when given function as a more than two product of function or as a division, in that case you couldn't solve by general method. Here I will suggest you, and I think in previous class I have also discussed many problems which is relevant to these methods, but here we will discuss mainly some different kinds of problems about which I have already told you in previous class. That problem will be as variable to the power variable, means that suppose that you let u and v are two functions. Let u and v are two functions. Let u and v are two functions of x. If u and v are two functions of x and y is a function which is expressed as y is equal to u to the power v, in that case you have to differentiate y with respect to x. And in that case, how can you manipulate? As you know that I have already told you, derivative of x to the power n with respect to x will be n into x to the power n minus 1. Only in that case where x is a variable and n is a constant. Another formula, derivative of e to the power x, derivative of a to the power x with respect to x, about which I have already told you, a to the power x into log a to the power x into log a. And this method, here you can tell me, sir, here a is a constant and x is a variable, but here u and v both is treated as a variable. In that case you cannot solve either method this question. In that case you have to take first log on both sides. There are two methods through which you can solve this kinds of problem. First method, see here, firstly taking log on both sides, right here taking log on both sides. In that case you will get log y is equal to log u to the power v. That implies that log y is equal to this v comes as a multiplication according to property of log. Here you can write v times log u. Now simply you have to differentiate on both sides. You can write differentiating on both side with respect to x. When you differentiate on both sides with respect to x, in that case you will get derivative of log y with respect to x, which will be derivative of v times log u with respect to x. As you know that log y cannot be differentiated with respect to x directly. Definitely, first of all, if you compare your standard formula, then you will get log y is directly firstly differentiated with respect to y. That implies that, can you write here this LHS, can you write it as firstly differentiate log y with respect to y, again you have to differentiate y with respect to x. And as you know that you have to find dy dx. So don't worry, by taking this term and by carefully separate this term during writing it. Now see here, this is a product of two functions log u and v. First of all, according to rule, it is a product of two functions. According to rule, first of all take the second term out of derivative terms, that means log u into derivative of v, that means dv dx plus In second case, you have to take v out of derivative terms and take as a multiplication derivative of second term, that means derivative of log v with respect to x. Now here again I will tell you, as you know that log v cannot differentiate it with respect to x, so there is no enough space, so I want to jump here only one step, that means firstly differentiate v with respect to v, again differentiate v with respect to x. Now as you know that u and v, sorry, there should be log u have taken, and there will be log u you have taken already, log u and differentiate v, again here taken v, and sorry here log u. Now as you know that u and v are function of x, easily you can differentiate, but now derivative of log y with respect to y will be 1 upon y, so there should be 1 upon y into dy dx, which will be log u into dv dx plus v times derivative of log u with respect to u will be 1 upon u into du dx. As you know that v and u are given, also you can differentiate v with respect to x, and as well as u also can be differentiated with respect to x, because u and v are function of x, and using simple method you can differentiate u and v separately. Finally you will get dy dx, which will be y times, as you know that this is in denominator of LHS, after going in RHS it will be in numerator of it, so it will be y times log u dv dx plus v by u into du dx. Now I want to write final step of it. Firstly rub this part, and its final step will be, see here, that implies that dy dx will be, as you know that what is the value of y? Value of y is equal to u to the power v into log u into dv dx plus v upon u du dx. For convenience, and I want to write as it v upon u and differentiate u with respect to x plus here there will be u, and again take log u into dv dx. You can remember this formula. To solve quickly any problem which is as variable to the power variable, that means function to the power function or variable to the power variable. Suppose that now I will suggest again second method for this question. You can solve this question also by second method, but first method, remember it, its answer will be u to the power v into v by u into du dx plus log u into dv dx. Now I want to rub this part and again try to solve this question second method. Second method is also very easy. As you know that y is equal to given that u to the power v. I have already told you there is a property which is relevant to log, that will be e to the power log u to the power v. Can you write u to the power v equal to e to the power log u to the power v? How? Because there is simple concept I have already told you. Fx can be written as under proper condition or under a proper restriction, you can write fx is equal to e to the power log fx, This is your proper restriction. Under proper restriction you can write fx is equal to e to the power log fx. So can you write y is equal to u to the power v is equal to e to the power log u to the power v? Now if you apply in its exponent part property of log, so you can write easily e to the power v times log u. Here you get simply y is equal to e to the power v times log u. Now suppose that this is your equation first. Now you have to again differentiate on both sides with respect to x using exponential function, that means e to the power x. That implies that you can write here, there is no enough space, so I want to write directly differentiating on both sides with respect to x. Then you will get dy dx is equal to derivative of e to the power v into log u with respect to x with respect to x. And you know that this is e to the power something, e to the power something, and you know that derivative of e to the power x with respect to x will be always e to the power x, but there is something different here. In place of x there is given e to v times log u, and that variable which with respect to you have to differentiate will be x, so you can't differentiate directly. So firstly treated this term as a single term. Here suppose that this is your single term v into log u. V into log u is a single term. Suppose that p, in that case it behaves as a e to the power p, and as you know that e to the power p only differentiated with respect to p with firstly, that's why can I write here differentiate e to the power v into log u with respect to v into log u firstly, again differentiate v into log u with respect to x. Simply can I write here? Now I want to rub this part here and see again here e to the power something. As you know that I have already told you, v into log u treated as or supposed as p. In that case it will be derivative of e to the power p with respect to p will be e to the power p. So you can write easily e to the power v into log u. This is your e to the power p into. Now you have to differentiate product of two functions. This is your first function you can treat. This is your first function. This is your second function. Now this is a product of two functions. Now you have to apply a simple product rule of derivatives. Now in that case it will be log u. Firstly take out of it log u and differentiate the v with respect to x plus. In second case take v out of derivative terms and differentiate log u. Differentiate log u with respect to x. And you know that you cannot differentiate with respect to x. That's why firstly differentiate with respect to u, and in second case I want to differentiate with respect to x, because it gives this part says to you have to differentiate with respect to x, but as you know that log u cannot differentiate it with respect to u. That's why I want to firstly differentiate with respect to u, then thereafter I differentiate here with respect to x. Now I think you understand very well. Now I want to again tell you, can you write e to the power v into log u what? E to the power v into log u, e to the power v into log u is equal to e to the power log u to the power v, and it can be also written u to the power v. Finally, can you write this as just as u to the power v, and into this is nothing, this is your take it dv dx. You can write here derivative of log u with respect to u will be what? Derivative of log u with respect to u. I want to write this term here and this term here. That will be very helpful. You can write here also. Don't worry by taking it. Log u into dv dx plus v into derivative of log u with respect to u will be 1 upon u. So it will be 1 upon u into du dx. I think you understand very well. Now I have arranged only. Nothing I have done here. Simply v upon u into du dx, plus log u into dv dx. This is your required answer. I think you can see here both procedure gives you a same result. In that means you can conclude here. You can proceed either method in your examination, but I will suggest you when you give your objective examination and you will face such kind of problems which is as variable to the power variable or function to the power function, try to always solve by this method using only this formula. That means u to the power, if there is a given expression as u to the power v, if there is given expression u to the power v, then you have to first write u to the power v into v upon u into differentiate u with respect to x log u plus log u into dv dx. Directly you can solve. Here you have to only identify which function is u and which function is v. Otherwise you can, and if you are giving examination in subjective types, you can solve by either methods. In actually this is your standard method, and that means standard method you can tell a smart method and first method will be general method. In general way every student solve by first method. Now I will take some questions which is relevant to your this exercise. See here. Now see here. First problem will be y is equal to x to the power x. Y is equal to x to the power x. Now you can tell me, sir, how can you solve tricky? That means in short time, as you know that this is your variable to the power variable. Simply, I have already told you, if any function as y is equal to u to the power b, and in that case its derivative with respect to x will be u to the power b into b upon u into du dx, b upon u into du dx plus log u into db dx. This is your formula through which you can approach near the solution of this question. Now you can tell me, sir, here if you compare a standard form of problems u to the power v, you can conclude u is equal to x and v is equal to x. That means u and v are both same x. Now you have to solve. That means its answer you can write directly through this formula. What is this? U to the power v, that means x to the power x, right here, and v upon u, that means x to the power x. Actually v is equal to x and u is equal to x, so you can write x to the power x into du dx. Du dx, as you know that u is equal to x, u is equal to x, so derivative of x with respect to x will be 1 plus log u. This is your log u, so you can write here log x because u is equal to x, and dv dx, derivative of x with respect to x will be 1, so it will be 1. You can leave. Now x to the power x will be 1, so it will finally give you 1 plus log x into x to the power x, which is your required answer. That means quickly you can solve so quickly. That means within 4 to 5 seconds you can solve if given u and v are so easy. Otherwise you can proceed by general method, as I will again give you two methods to solve this problem. First method you can see here. First method see here. Firstly take log on both sides. You can write here taking log on, firstly write here taking log on both sides. Thereafter you can write, this is your equation first. This is your equation first. You can write log y is equal to log x to the power x. In that case it comes here log y is equal to x times log x. I think you understand very well. Now you have to differentiate on both sides with respect to x, and I will try to jump here sometimes because there is no enough space. See here, if you differentiate with respect to x, if you will tell me, I will write again it's a step derivative of log y with respect to x, which will be derivative of x times log x with respect to x. I think you understand very well. Now again I will tell you derivative of log y with respect to y firstly, thereafter you have to differentiate y with respect to x. This is your first. Again here, this is a product of two functions. So simple product rule you have to apply, and firstly take log x out of it and differentiate x with respect to x, which will be 1 plus. You can write here, if you have a time and with a space, you can write here. Again take x out of it and differentiate log x with respect to x. I think you understand very well. Now see here again. Derivative of log y with respect to y will be 1 upon y into dy dx, and derivative of x with respect to x will be 1, so I want to write 1 into log x, which will be log x plus x into derivative of log x. Derivative of log x will be 1 upon x, x into 1 upon x will be 1, so it will give you directly to u1. Now you can say here, I will suggest you again in next question I will sometimes jump, so be careful here. Whenever I will differentiate log y with respect to x, I will directly write this line. Why? Because when you differentiate log y with respect to x, then firstly differentiate log y with respect to y, thereafter again you have to differentiate y with respect to x. It will give you 1 upon y into dy dx, so I will directly write this line. So don't worry while I am writing these steps directly, and as usual way I will write your RHS. Now finally you can tell me, sir, it will definitely give me dy dx. You can write here dy dx will be y times this term, because y is in denominator of your LHS, while it will go in RHS, it will go in numerator. So it will be dy dx is equal to y times 1 plus log x. Y times 1 plus log x. As you know that y is equal to what? X to the power x. So you can write x to the power x into 1 plus log x. This is your correct answer of this question. You can see here by both methods you will get same answer. There is also third method, because this is your tricky method. Is by shortcut directly you can approach your answer, and there is also other method. See here other method again. which is your third method. And thereafter I will always solve mostly your second or first method, and thereafter you have to do practice by all methods. See here, third method. Y is equal to x to the power x. As I have already told you, can sorry, here y is equal to x to the power x. If y is equal to x to the power x, can you write it as e to the power log x to the power x? Why? Because this is fx. This is the fx, and I have already told you many times before it. Earlier class I again also told you x to the power x can be written as e to the power log x to the power x. That means fx can be written as e to the power log fx. Now you can see here, if y is equal to x to the power x, which will be e to the power log x to the power x, then it will be e to the power. Can you write x times log x? Can you write e to the power x times log x? In that case, you will get to y is equal to e to the power x into log x. Now you have to differentiate on both sides. Thereafter you will get definitely dy dx. I want to write here directly derivative of e to the power x into log x. Firstly, with respect to which you can write here with respect to x, but as you know that you cannot differentiate with respect to x directly. That's why I want to firstly differentiate e to the power x into log x. Firstly, with respect to which function? X into log x. Then you have to differentiate x into log x with respect to x. Now you can conclude e to the power something with respect to something which is same. That means suppose that x into log x is equal to p. In that case, e to the power p differentiated with respect to p. Definitely it will give you e to the power p. So it will be your e to the power x into log x. Now in second term, if you see here both function is as a product. That means x into log x. When you apply here product rule, definitely you will take second term out of its derivative term and differentiate first term with respect to x plus. There in second step you will take x out of it and differentiate second term with respect to x. That means x derivative of log x with respect to x. I think you understand very well. Now as you know that e to the power x into log x, what is its value? As you know that e to the power x into log x is equal to this term, it is equal to this term. Can you write in place of it this term? Yeah, you can write. So you will get dy dx is equal to x to the power x, that means y into as you know the derivative of x with respect to x will be 1 times log x is equal to 1. So you can write directly log x plus here x into derivative of log x with respect to x will be 1 upon x. X times 1 upon x will be 1. So it will be 1 plus log x. So finally you will get x to the power x into 1 plus log x. This is your correct answer of this question. I think you get in all cases x to the power x into 1 plus log x. Have you understood very well? Now you have to choose which method will be far better for you and try to solve by that method in your examination. It depends upon your examination is in which mode, that means subjective mode or objective mode. When you will get in your examination is objective mode, try to remember that formula. But mostly, why do you remember that formula? You can also jump some steps and directly get your answer. This is not very lengthy as a previous problem. That means earlier class I have discussed some problems which is more lengthy than this problem. So I think it is also average. That means no very lengthy. And if you go through tricky, it will be more beneficial for you. Now I will take next problem. Some good problems for you. See here. Some good problems for you. See here. Next problem will be sin x to the power log x. Second problem, see here. Y is equal to sin x to the power log x. Sin x to the power log x. Sin x to the power log x. See here. 1 minute wait. Y is equal to log x to the power sin x to the power log x. Now you have to differentiate. You can go through your trick. What is trick? You can write. I will again use it. Dy dx will be directly write here u to the power v. This is your u. This is your v. U to the power v. That means sin x to the power log x. Thereafter second step will be what? V to the power u. What is v? log x by sin x into different derivative of u, that means sin x derivative of u, that means sin x derivative of sin x will be what? Cos x. You can plus in the second term log u. What is log u? Log sin x. And derivative of u, that means derivative of u will be what? Derivative of u and derivative of b, there will be derivative of b, derivative of b will be what? Log x, derivative of log x will be 1 upon x. This is your answer. You can see here. What is formula? You can write here again. This is u to the power b, and its answer will be u to the power b into b upon u into derivative of u into derivative of u with respect to x. Again log u into derivative of b with respect to x. This is your that means a trick through which you can approach you direct your answer. But I will suggest its second method. Actually mostly I will suggest go through e to the power form, because it will be very helpful, easy, and not very lengthy, or do not face your problem by taking log. Can you write y is equal to sin x to the power log x as e to the power log sin x to the power log x? Can you write? Don't bother by taking it. It is more lengthy and complex, because it is very easy. Log a, as you know that property of log a to the power b can be written as b times log a. I think you know very well in 9th or 8th class. Can you write it as e to the power log x into log sin x? Log x into log sin x. Can you write? Now y is equal to this term. Y is equal to this term. Now you have to differentiate on both sides with respect to x. So can you write differentiating on both sides with respect to x, dy dx will be, first I differentiate this term with respect to x. Derivative of e to the power log x into log sin x with respect to x. As you know that you cannot differentiate with respect to x directly. That's why firstly differentiate e to the power log x into log sin x with respect to which function? Log sin x into log x into log sin x. Thereafter you have to differentiate log x into log sin x with respect to which function? X. I think you understand very well. Now say if you here you have differentiated with respect to x. Now I want to rub over, it's your part. Now you will see derivative of e to the power something with respect to something will be same. That means can you write e to the power log x into log sin x? I think you can write very easily into derivative of log x with derivative of log x into log sin x with respect to x. How can you write? It is as a product. Firstly take second term log sin x, firstly take and differentiate log x with respect to x. That will give you 1 upon x. Plus again take here log x out and differentiate this term. When you differentiate this term with respect to x, firstly differentiate with respect to sin x, because this is your log sin x, and derivative of log sin x with respect to x you cannot write directly. That's why you have to write firstly derivative of log sin x with respect to sin x, and in second step you will write derivative of sin x with respect to x again. In that case you will get here log sin, that means here you have taken a log x out of it and differentiate log sin x with respect to sin x firstly. In that case firstly you will get its denominator sin x, and derivative of sin x with respect to x will be what? Cos x. Now you can tell me this is what in actual way this is your question. How? Because you can tell me this e to the power log x into log sin x. What is this? This is your e to the power log sin x to the power log x. This is your actual way. This is your actual way sin x to the power log x. Here I have rubbed this part. You can see here I have written already e to the power sin x to the power log x. Sin x to the power log x. This is your real expression. So can you write here again sin x to the power log x, sin x to the power log x, and here will be log sin x by x, log sin x by x plus cos x by sin x will be cot x into log x. This is your correct answer of this question. I think you understand very well. I think you understand very well. Now again I will tell you, or I will give you next problem for you. I think third question is similar, only differ by log x in place of sin x. It has given you sin log x, and in place of sin x it has given log x. Otherwise everything is same. Still I will solve that problem, and I will suggest you can solve by trick. Second problem will be third. See here, y is equal to log x into the power sin x. If you solve by trick method, you can see here, this is u, this is v, and you have to write it as simply. Can I write dy dx is equal to u to the power b? That means its first term will be log x to the power sin x. Second term will be derivative of u to the power b, derivative of second term v upon b, v upon u, and differentiate u with respect to x, 1 upon x plus. In next step, write here log u in place of u is log x. So log u, that means log x into, and differentiate v with respect to x, derivative of sin x with respect to x will be what? Cos x. As a multiplication, it is multiplication in both term, so it will be your actual answer of this question. Now I will go usual process. See here, how can you proceed as usual process? See, can you write it as e to the power log? I want to write directly some step jump. Can you write e to the power log x to the power sin x? Can you write? Now if you understand, in next step I want to write e to the power sin x into log x. Can you write? I think you understand very easily. This is very easy expression. I have taken only sin x as a product here. In its is log x in terms. That means sin x e to the power sin x into log x. This is your y. This is your y. Now you have to differentiate on both sides with respect to x. After differentiating on both sides with respect to x, you will be dy dx. You will get dy dx, which will be derivative of e to the power sin x into log x. And suppose that this is your single term p. If this is your single term p, then e to the power p firstly differentiated with respect to p. So I want to write directly. If you give me some time, I will definitely write its step also. That means c to the power sin x into log x. Firstly differentiated with respect to sin x into log x. Log x. Again you have to differentiate sin x into log x with respect to which function? With respect to x. I think you understand. Now here see, e to the power something. Suppose that this is your e to the power p, and you have to differentiate e to the power p with respect to p. Definitely it will give you e to the power p. That means same. So it will be e to the power sin x into log x into log x into. Now here see, what is this? This is your product of two functions. This is your first function, this is your second function. Now you have to firstly take which function? Second term out of derivative of first function. That means log into log x into derivative of sin x with respect to x right here in second step as a product. Plus in next step you have to take sin x out of derivative of second term. That means sin x into derivative of log x with respect to x. I think you understand very well again. Now I will write your next step. For you. See here. Now I want to write directly. As you know that this is nothing. This is just as this. So can I write directly log? It will always come in your problem, in its your answer. See, this is your log x. Can I write it directly? Because there is no manipulation in it. Now derivative of sin x with respect to x will be cos x. So you can write here cos x easily plus. Now here it will be sin x. And differentiate log x with respect to x. What will be its answer? Derivative of log x with respect to x will be firstly differentiate log x. I want to write here its explanation. Firstly write derivative of log x with respect to log x. Again differentiate log x with respect to x. As you know that log x with respect to x. In 1 second, suppose that this inner log x is p. inner log x is p. In that case, it will be log p with log p differentiated with respect to p. It will be 1 upon p. What is 1 upon p? 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 1 upon p. What is p? P is log x, so you can write 1 upon p. Now, a derivative of log x with respect to x will be x. So this is your actual answer of this question. I think you understand again very well. Now I will take again your next question. See here. You can proceed either method. Don't worry. You can take by taking log general method, a smart method, or your third method. That means very tricky. Now I want to take some next kind of problem. Next problem will be